Hey folks, I wanted to walk you through really quickly this little fun project where Yaroslav wanted to what would it look like if we used our sort of agentic coding setup to reimplement 50 something, 50 plus implementation of Geoffrey Hinton's work, research, and papers, problems introduced over basically a lot of his work. So this conversation, just to give you an idea, it started out from our Telegram channel where usually a lot of the magic goes down, the Sutro, and then specifically this channel, which is the channel where I do a lot of my spam posting it. But specifically, this is the message that started off, which was like, hey, look, we have an example of this paper implementation. What would it look like if we wanted to do more of this? So that's the starting point. And if none of the things that I am going to say make sense, there is a follow along file called build notes that you can look at. And the other important things that I want you to keep in mind is that there is a starting point of the entire loop, and it's this GitHub issue. Okay, so what ended up happening? How did this work? So first, if you have been following the group, we have a little research environment that's called Sutro Yaro. So this repository, if you clone it and if you run Codex or Claude Code within it, you're going to be able to connect it to the Telegram conversation, the different channels, and you're also going to be able to connect it to the Google Docs where a lot of the meeting notes go to. So it's like a kind of three-body problem type of situation going on, right? You have a bunch of implementation problem definitions here. And ideally, besides the coding agent, you also have access, or your environment have access to GitHub using the GitHub CLI, because that's what the agent will use to communicate beyond the Telegram and the Google Doc, which is the toolkit that we have in this repository. So why am I talking about that? Because this is how I communicate pretty much with when I try to follow up. So when I try to see, like I open up this repository locally, like, hey, what is Yaroslav talking about? Hey, what is the team working on? Is there a new interesting thing that I can read? And that way that the coding agent, in this case Claude Code, ends up pulling it. It's like, oh yeah, it looks like there has been a new repo. There's a new thing introduced. And so the same way, I started out by saying, hey, it looks like we have a mission, and the mission is to go to the moon. No, to basically pull in this repo and look at that one specific paper implemented, and then based on that implementation, let's create a specification. So that's it. There is no magic, really. There is nothing, no extra plug-in, no extra, nothing really, other than, hey, this is what's going on. This is the in and this is the out. Let's capture it. Let's create a plan, and how are we going to do this 50 more times, ideally efficiently. And so the thought process here is that if you end up using a team of agents, which is what we used here, you want it to be controllable, okay? You want it to be repeatable. Ideally, it's not a thing that just magically one shot works. And ideally, it is to a certain degree observable, meaning that you know when it will start doing things terribly wrong, which they do often. So that is part of your duty to figure that out. Okay, so how did I go about then translating this specification into a bunch of implementations? So this is the first step. The first step of collaboration is that I got the agent to read the problem, create a spec, create a GitHub issue on behalf of me. So this is not me posting, it's on behalf of me from the terminal. And then Yaroslav was able to very gracefully add a comment to correct some of the little extra happy details. And that is important. That's why you need the collaboration. Otherwise, you can go to the deep end. And so that was the first step. Okay. So now the second step is that we are trying to figure out, and so this is just to kind of give you an idea. Really, it looks something like this. So this is the repo, as I mentioned, Sutro Yaro locally. I open it, and then obviously I have some previous context, some work going on there. This number is wrong. Don't worry about it. It is actually 700K. I will mention why it's that. So within this session, I provided the agent the spec, or rather I asked the agent to create the spec by providing it this repo, and then I asked the local Claude Code agent to also read the Telegram conversation. And then after that, we were off to the races. And so this is sort of like the synopsis, the chain of events that lead up to finishing the 50 implementation in about 6 to 7 waves. Actually, it's about 11 waves. Okay, so what is a wave? Okay, so when I first got the Claude Code agent to understand what we were doing, like this is the in, this is the out, I kind of had the agent create these batches. So the batch would be a team of agents that would implement a category of problems that are all around the same subset of problem sets. So that way you're not constantly swapping in and out a different agent. Ideally, one agent understands a category of problem that it can solve. You don't need to explicitly say this. However, one thing that you do explicitly have to say is some very crude language like this one, which is getting the agent not to come up with skills and other noisy plugins that you have, but specifically to use the built-in orchestration team that Claude Code comes with. In one of the previous videos, I have talked about the differences between the set of sub-agents and agent of teams. The main difference is that agent of teams, per each wave, per each batch of work, it creates a Git work tree and it has a dedicated team of agents. And more importantly, it will use the most performant model. When you're using sub-agents, when it tries to do that little cute thing, looks like it breaks the tree in one terminal, it doesn't do that. It ends up using a smaller model. So those things you end up finding out when you try it out a couple of times. So that is what's really going on. And so one question to be asked and also answered here is that how do you get this thing when people are like, oh, I've been running it for 3 days. This is how you get to run it for 3 days. You basically have the agent create these waves and you have something like, hey, when this wave ends, do a review, and then when the review ends, dispatch the next step. And so all of that can be created just by doing that initial description. And since that we have 1 million context window, you're actually going to be able to just keep that almost ephemeral without any hard rules being written down. Okay, so I'm going to speed through really quickly to make this more productive because this is sort of straightforward from here. You can see what's going on, a bunch of back and forth. So this is what the loop looks like. Again, within the Sutro Yaro, how I had initiated creating another local repository, pulling in the repo, creating the spec, creating the agent of teams, and then that's it. From that, I do not say create a work tree. I do not give any further instruction. I do mention create a PR per each wave. And then when you do so, I do also provide this sort of extra thing that, hey, do an audit for every pull request. Do not allow the agent to just casually merge things and destroy the code base. So do a PR. And then the PR, only when yours truly get to approve it, should be merged. Okay, so this is a little bit stat of what it looked like over the span of 30 hours to implement all 50 plus papers. About 200 bash calls. If you ask me, this screams that a toolkit can be created. So whenever you have a lot of bash calls, it could actually translate to one CLI tool, and that CLI tool can take you from step 1 to step 4 immediately. What usually ends up happening in some of these scenarios when it says file ops, it's actually doing something like ls, it tries to read, it tries to edit, it tries to do tail. So those are little improvements. If I were to do this again, I would do so. But okay, so probably what I think would be more interesting to look at is actually, so these are the waves. So yeah, so these are some of my conversations back and forth. Sometimes I do get really angry, so don't mind me if you saw any swear words here. But yeah, so I did not really budget it. I do usually budget the agent that it should not spend more than, like million tokens. I mean, that's crazy. But it was able to do this under 800K, not only for the implementation, but also to publish a website, an MD book with all the results, with the problem definition. And yeah, I mean, this is very cool. This is like almost like a little survey paper with the stats. It not only that, it's actually able to tell us that some of the implementations are 25 of them, I think, are reproducible exactly like the paper. About 20 something of them are have like some details are off, like gap, some stuff documented. One of them requires a GPU, or I think it's actually the capsule net, I think that's the paper, if I recall, is the one that had a little hiccup in. Other than that, it was able to implement pretty much everything. I'm trying to think about what else is relevant. Yaroslav created a really cool visualization, or rather a page. Let me see. Oh, I guess like this is something maybe useful to look at. So, at some point around 20-hour mark, it started getting spammy. So this is something, I don't know, this is speculation, but oftentimes when there's a downtime on Anthropic's and they do switch the model without you knowing, and then it does stop following some of the tools. So that's unfortunate, but we were able to get back on Opus 7, 4.7, Opus 7, 4.7, where I caught it. I caught it in the middle of it trying to create a PR for every implementation. So that was going to be nightmarish. I was like, no, 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 that's not what we have to do. Instead, we have to create a PR per each wave. So those are little caveats that you might have to catch if you're trying to implement something similar. Oh, this is what I was looking for. So this is like this is like really beautiful. Just looking at this kind of makes you want to do research. But yeah, I hope this is useful. Other than that, really nothing extra, nothing magical. Just logically trying to think through how you create a spec, how you're going to use the team of agents, how you can break down, and then have the agent build the problem back up. That's really controllable, observable, ideally repeatable, so that way you can stop it. If it destroys things, you can stop it, and you can give the session ID to another agent, and the other agent can pick it up. That's pretty much it. Peace.